Okay, the objective for this lesson is that today you will learn the vertex form of a quadratic function and how to use it to determine the vertex, line of symmetry, and other important information about the graph of the quadratic. First, you'll remember that the standard form of a quadratic equation is ax squared plus bx plus c equals 0. Now, that's what we've been using the past few lessons to work the quadratic formula, and we used that method when we were factoring as well. But if you'll remember way back when we first started talking about the parent functions, and we talked about the parent function of a quadratic, it looked something like this. This form right here. This is called the vertex form of a quadratic. And you'll remember that it is a quadratic because the power is 2, but also there is a transformation that is happening here, and that's happening with the variables h and k. You remember that it shifts the parent function. It shifts it either left or right if it's on the inside of the parentheses with the x, and it shifts it up or down when it's on the outside of the parenthesis or of the parent function. Okay, so today we're going to explore this vertex form of a quadratic. Now, the vertex form of a quadratic tells you a lot of information. It can tell you whether or not the equation opens up or down. Now, I said equation, but what I meant was the graph. It tells you whether or not the quadratic is either opening up or down. Now, that is all based off of this first coefficient right here, which is the letter A. The A is going to tell you whether or not it opens up or down. You should remember that from when we talked about the parent functions. If A is positive, then you know that it's opening up. If A is negative, then it will be opening down. It's been a long time since we talked about that with parent functions, but hopefully you still remember that. Okay, the other piece of information is that if you remember back when we talked about parent functions, we talked about how it moves the vertex either left or right or up and down. Now you can see here that with the way that the way h and k is here, okay, well if h is on the inside, that's telling you that it's moving to the right. Because remember, it's always the opposite of the sign, opposite of common sense. The k on the outside is telling you that it's moving up. Okay, so for in the generic formula, the vertex formula of a quadratic, your vertex can be determined. It will always be the ordered pair HK. So you will take the H out of the form, and that is your x coordinate of the vertex. You take the K out of the form, and that is the y coordinate of your quadratic. Okay, now let me back up a little bit. We talked about whether or not the quadratic is going to open up or down. Okay, and we said that when A is positive, the quadratic is going to open up. Okay, so here is an example of it opening up. Okay, this one is opening up. Now, this point that's right here in the middle, we've talked about this before. The name of that point is the vertex. So here is where the vertex is going to be, and we already talked about how you can find the vertex. It's always going to be the coordinate HK. So whatever number is in place of H right here is going to be the x coordinate of your vertex. Whichever number is in the place of K right here, that is going to be your y coordinate. But when you're looking at the picture, this is where your vertex is. It's right here. Okay? Now, if it is opening up, then we call this vertex a min, which stands for minimum, because it is the very minimum point of the quadratic. Now, in another case, when a is negative, the quadratic is going to be opening down. This time, the vertex is up at the top, right here, and we call that a max, which is pretty much common sense. The max is at the top. It is the very top point of the quadratic. So sometimes they will ask you that. They will say, is the vertex a min or is the vertex a max? And you need to understand that you get that information from knowing whether or not the quadratic is opening up or the quadratic is opening down. Okay, now there's another good piece of information that we can get from this equation, from the vertex form. It is the line of symmetry. Line of symmetry. Now, the other way that they describe the line of symmetry is sometimes they will call it an axis of symmetry. So if you see either word, it means the same thing. Axis of symmetry, it means the same thing as line of symmetry. Now, where is the line of symmetry? Well, you can kind of guess where it's going to be. It's going to go right through the vertex. It's going to be a vertical line that is going through the vertex. So over here, my line of symmetry, it goes right through the vertex. It is a vertical line. Okay, why do we call it the line of symmetry? It's because the quadratic is symmetrical on either sides of that line. Okay, well, if you remember how to write the equation for a vertical line, we are going to say that that is x equals, well, what point is it going through? It's going through this point right here. It's going through this point right here. And so the x value of that point is what. Okay, and then this last piece of information, it says if a is greater than 0, the graph opens. Well, if a is greater than 0, that means that a is positive, and so the graph is opening up. If a is less than 0, that means that a is negative, and so the graph is opening down. Okay, now remember at that point, that tells us whether or not the vertex is a min or whether the vertex is a max. Okay, so we will look at that. Let's look at a few problems and let's see how you're going to do this. Okay, the first problem on your notes page is this one right here. Y equals x minus 5 quantity squared minus 2. You can see that it is in vertex form. Now, what is the a? Well, the a is, we assume that because there is no number there, right, that we can't see it, we assume that that number is a 1. Okay, so the a is a positive 1. So right off the bat, I would start there and I would say, okay, well, is it opening up or is it opening down? Hopefully you realize that it is opening up. So visualize that in your mind. If it opens up, is the vertex a max or is it a min? Well, it will be a min because again, when it's opening up, you got to think about where that vertex is. The vertex is right down there at the bottom, so that makes it a min. Okay, well, what is the vertex? Well, if you remember, the vertex is your h and your k. Now also pay attention to the sign. The h is 5. Remember, in the equation, we have a minus there. We have a minus in this equation too. So that means that the h is that positive 5. Now, if in here this was a plus, then of course the h would be the negative. Okay, so you just got to kind of remember that when it's in the parentheses, again, it's the opposite, all right? So the h is 5. The k is -2. Okay, so the vertex is 5, -2. Now, one place that you can make a mistake there is that some people will take the exact sign that they see here and here, and they will put that the vertex is -5, -2. Don't make that mistake. If it's in the parentheses, you take the opposite, so it's going to be a +5. At the end, it's on the outside, so you're going to keep that sign. It is a -2. Okay, well, what is the line of symmetry? Well, if you remember, after you graph your vertex, well, let's go over here to this graph and let's go ahead and graph it. If you go to 5 and you go to -2 and you put a point, okay, the line of symmetry is going to go through that point. It is on the vertical going through the vertex. So it looks like this. Well, how would you write the equation for that line? Well, it's going through the x-axis. That means that every point on that line is going to be 5. So the equation for the line of symmetry is x equals 5. All right, and then I want you to go ahead and graph what this picture looks like. Now, you don't have to have the exact points. I'm not going to be real picky on that right now, but I want you to keep these things in mind. You've already got your vertex graphed, and you need to be thinking about how it's going to open. It opens up. So now you can go over here to this graph, and you can try and draw as symmetrical as you can a graph. Okay, so let's stop here and let's pause the video, and I want you to try and work the next one on your own. So let's work number 2 on your page. I want you to try and work on your own, and then hit play again when you're ready to check your answers. Okay, so I hope that you were able to work through it well. Let's check your answers. I hope that first you checked your A and you found that the A was positive, and so you know that it is opening up. You should have also gotten that the vertex was -4, 2. I hope you also, because it is opening up, I hope that you wrote down that that was the min. And the line of symmetry is going to go through the vertex, so you should have gotten x equals -4. Okay, and hopefully this is close to the picture that you got when you graphed it over here. Notice that I've got my line of symmetry right here. Okay. And then you also see that I have my vertex here, and then my quadratic is opening up, and so I did that there. Okay, now the other thing that I hope that you're thinking of is way back when we talked about the parent functions, when you had this number out here and it was bigger than 1, then what was happening to this graph? Yes, it is stretching. So if you notice, the quadratic would have been, these points would have been down here, right? But because it's stretching, then it's getting multiplied by 2, so the point is up here. Just something to think about. I'm not going to be real picky about that right now, but again, I do want you to be thinking about that, how to correlate it to what we learned at the beginning of the year. Okay, pause the video again and please work through the next example. Okay, so for this last example, I'm going to leave this to you. And when you're done watching this video, if you will please fill out the WISC document at the end of this video and submit it online. This is your secret question. So in the WISC document, I will refer to the secret question, and this is it. So you will be putting some of the answers from this question in your document that you're submitting to me. Good luck and study well.